The second lesson for Unit 5 is evaluating special angles. Now, obviously, sine and cos and tan, you're not going to be able to memorize what these functions do, for a question like the ones we were doing yesterday, like what angle has an inverse a cotangent of 2 over 7. I mean, to know that that angle is 74, you're never really going to be expected to know something like that. However, there are certain angles, 30, 45, and 60, which you should be able to get without use of a calculator. And what I would suggest for this section is you just keep these like this actual physical page here, like page 10 or whatever. It may not be page 10 on yours because I've been adding spaces and stuff, but the first page of lesson 2, where you see these two pictures. Okay. Oh, I see. Okay, I was just looking at this like that's not the right picture, but anyway, it is the right picture. I just didn't understand why. So just have this with you, and this will help you. It will really help you just know these special triangles. These are things you should know. Okay, let's start with the first triangle, which is the 45, 45, 90 triangle. So fairly easy to draw one of these. We're going to make a point at 0, 0. We're going to make a point at 1, 0. We're going to make a point at 0, 1. And we're going to make a polygon that connects A to B to C, right? And you can see, GeoGebra does the smart thing. It puts lowercase b across from capital B, lowercase a across from capital A, and so on. Now, in this triangle, the angles are 45, 45, and 90 because the two sides are equal, and when you have two equal sides in a right triangle, you have to have a 45-degree angle. Now, if you type sine 45, you get this number 0.707. Okay, so let's round it to 4 decimals. So 7071. Now, that number is an irrational number. And of course, it never terminates. So when you get down to a question like this one that says find the exact area of this triangle, and there's a 45 degree there, you think, well, wait a sec. Sine of 45 degrees is an irrational number, and I need sine in order to get this opposite here, so how am I going to get an exact area if I'm using an irrational number? So what we're trying to do today is figure out which irrational number this is. What is this number, 0.7071, and so on and so on. So the ratios in this triangle are 1 to 1 to, sorry, where is this thing? To square root 2. Okay, and that's what this side A is. You see A here, 1.414213, etc. If I do A squared, I get exactly 2. So the three sides in this triangle are 1 to 1 to root 2. And of course, if you ever forget that, you just use the Pythagorean theorem. 1 squared plus 1 squared equals root 2 squared. And that would be the missing side for that one. So let's write this down. So 1 to 1 to root 2 is the ratio that this is going to have. And this means that if you look from the perspective of from one of the 45-degree angles, right? Just make this a bit bigger. Okay, let's look from the angle beta, right? So sine 45 degrees. Let's do this in the equation editor so it actually looks decent. Sine of 45 degrees, okay? How would you get this? You would do the opposite, which is a 1, divided by the hypotenuse, which is a square root 2. Okay, I clearly typed something quite wrong there. Okay, so sine 45 is 1 divided by square root 2, because the opposite is a 1 and the hypotenuse is a square root 2. Okay? Now when I go back here and I go 1 divided by square root 2, that's where this 0.707106 number comes from. Okay? So you know that okay, for most trig work, you just use your calculator. However, for certain angles, I will expect you to know the exact number. Some calculators will do this for you, by the way, but most don't, so I'm just going to teach you as though yours does not. Okay? So 1 over root 2, you can replace sine 45 with 1 over root 2. Similarly, you can replace cos 45 with 1 divided by square root 2. Oh my. Sorry. Okay. I can never type this right. There we go. Okay, cos 45 would be the same argument. The adjacent is a 1. Let's say we're looking from the perspective of this angle. The adjacent is a 1. The hypotenuse is a root 2. Now the tangent of 45 is equal to the opposite divided by the adjacent, which is just 1, right? Because it's the opposite is 1 and the adjacent is 1. Now the reciprocal trig ratios, let's just copy paste them. We know that sine becomes cosecant, cos becomes secant, and tan becomes cotan. And all of these answers are simply the same answer but flipped over. So instead of 1 over root 2, I'm going to put the root 2 over the 1, which is just equal to root 2. Again, secant is the same thing. It's just equal to root 2. Cotangent is equal to 1 because the reciprocal of 1 is just still 1. Okay? So you should know these three. And of course, you should be able to get these three by just flipping them over. But the first three, you need to know. So again, you have the benefit of having this page with you whenever you're doing any assessments, so just have it with you, right? But yeah, so the exact value for 45 degrees, we know it's 0.707, but in a deeper way, we know it's 1 over root 2. Now let's apply this same idea to a 30 and 60 and 90 triangle, which looking at this, it is not, right? This is a 60, 60, 60 triangle. So let's just see what they're going for here. So what I'm going to do, I'm going to draw an equilateral triangle. So what I'm going to do is I'm going to put a, let's see, how do I want to do this? I guess I'll put it, so we'll put one at 0, 0. We'll put one at 2, 0. And then we'll go polygon, AB, and we want 3 vertices so that it draws an equilateral triangle with 3 vertices. And if you check their angles inside, you see that all the angles are 60. Now, so we can also use this idea to get some exact values in terms of trigonometric ratios. To do that, what we're going to do is we're going to draw a line segment from point C to point x of C, but y is 0. Okay, so we're going to split the triangle in half. Now when we do that, let's just change it so it looks a little bit different. Change, so just don't show this object, or don't show the label, okay? Alright, so this is what we've got now. Now if you look closely, okay, this line that I drew halfway down the triangle splits this particular angle up here in half. So let's make a point right down here. And now let's measure the angle from D to C to A. Or sorry, from A to C to D. And you can see that the little angle in there is a 30. And of course that makes sense because I took the 60-degree angle from the top, which I'm just going to hide now, and it's now a 30-degree angle. Okay? Now what do I know about this triangle? I made every side of this triangle length 2. Okay, just to go back to my grid for a second. Right? This point was 2 points away, and this point was also 2 points away from A to C. If you go segment A to C, you see it has a length of 2. So this side has a length of 2, the bottom has a length of 2, this side has a length of 2. Now, of course, the bottom, let's get rid of that stuff, sorry. Okay, so this side has a length of 2. The bottom, the whole thing along the bottom has a length of 1. Has a length of 2. But since I split it in half, this part has a length of 1. Okay, so think now about the triangle that we are talking about. So what I'm going to do is polygon CDA, and let's just hide the other one for a sec. Let's hide the old one. We're just focused on this smaller one. The bottom is length 1. The hypotenuse is length 2. What would be the height? Well, we know that the hypotenuse squared, right, equals the 1 squared plus the height squared. We just don't know what the height is, right? So what if we did 4 take away 1 equals h squared, right? And therefore 3 equals h squared, and therefore h equals square root 3. I think it's like that. 3 without the bracket. Okay, so I'm using the Pythagorean theorem to determine that what is going on over here is square root of 3. Oops, sorry, got to use the other slash. Okay, oh, yeah, other bracket. There we go. Okay, so in this triangle, you have the hypotenuse is 2. The longer side of the two other sides is root 3, and the shorter side is 1. So let's just hide these labels for a sec so this is not so confusing. Let's hide that label, and now you can see what we need. Let's quickly give a measure of angle CDA, just to show that it's 90 degrees down there in the corner. And let's bring this onto our sheet now and do what we need to do with it. So I'm going to sort of paste it underneath here, because I think what their idea here is good to just keep it, like show where this came from, right? Like we split up an equilateral triangle, and that's how we drew this thing. Okay, now look from the perspective of the 30-degree angle. So in my case, the 30-degree angle is up in the top. And if I look from this perspective of the 30-degree angle, the opposite is 1, the hypotenuse is 2, the adjacent is square root 3, right? So let's type our ratios. Sine, okay, so sine of 30 degrees, okay, yikes. Sine of 30 degrees would be the 1, which is an opposite, divided by 2. Now this is interesting because when you actually do sine of 30 degrees, you shouldn't get a decimal. You should just get a clear fraction. And when I do sine 30, okay, I get 0.5. And even if I round it to 10 decimal places, it's still 0.5 because it's an exact number. It's actually not rounded. This is a special example of where the sine or cos is just a regular, rational number. Cos, okay, let's look from the perspective of 30 again. My adjacent would be this side, which is the root 3. My hypotenuse would be 2. So cos of 30 degrees is equal to square root 3 divided by 2. Okay? And tangent of 30 degrees would be equal to the opposite, which is 1, divided by the adjacent, which is square root 3. Okay, and I think... Oh, okay. Just delete that there. Okay, so there you go. So there's the sine, cos, and tan of 30. Of course, to make the other ones, to make cosecant, secant, and cotangent. Okay, all I got to do is just flip these over. So cosecant of 30 is just 2. Secant of 30 is 2 on the top and square root 3 on the bottom. And cotangent is just the square root 3 on the top and the 1 on the bottom. Of course, a 1 on the bottom you don't really need to worry about, so we'll just say it's root 3. Okay? And those are your reciprocal ratios now for a 30-degree angle. Again, I don't think you need to memorize the reciprocal ones. I would memorize these ones, and then you could always just flip them over when you needed to. Okay, for 60 degrees. Now looking from the perspective of 60 degrees, the opposite is square root 3, the adjacent is 1, the hypotenuse is 2. So let's, it's going to be very similar to the one we just did, but not exactly the same. So sine of 60 degrees, okay, the opposite is now square root 3, and the hypotenuse is 2. For cos of 60 degrees, this one you get the 1/2, is nice and easy. And for tan of 60 degrees, you get square root 3. Because you get square root 3 is the opposite divided by 1, which is the adjacent, which you can kind of ignore the 1. To create the reciprocals, again, sine becomes cosecant, cos becomes secant, tan becomes cotan. And all of these things need a 1 over. This one, becomes, put the 2 on the top and the 1 on the bottom, just becomes 2. And this one becomes 2 over root 3. Okay, so they just flips over. Okay, so again, this table, very important. Put a tab or whatever on this page so that you have access to it and that you're using these. Challenge yourself to use these exact values where possible. They will help you a lot to just understand and not get lost in terms of what you are doing in this unit. If you can remember, what does sine do? It takes an angle and gives a ratio. Well, in this particular triangle, you know the ratios. You know all of them. We just went through them all. And you can recreate them yourself pretty easy, as long as you remember that this triangle is 1 to 1 to root 2, and this triangle is 1 to root 3 to 2. If you can remember that, then you can recreate these ratios as needed. So now for some questions related to this sort of thing. It says, find the exact value for each trig expression. Again, this means no decimals, and really it means no calculators. Now, of course, I can't stop you from using a calculator. I don't want to. But what I'm saying, you should be able to do it without one. And if you can't do it without one, it means something is missing in what you understand. Because it shouldn't be too difficult to do these ones without a calculator. So, for example, this first one, it says sine 45 times cos 45, take away sine 30. Now, of course, I could type that into GeoGebra and get an answer, but I don't need GeoGebra because I know a couple of things. I know, for example, that sine 45 is 1 over root 2, right? And I know that cos 45 is also 1 over root 2. Okay, and then I'm supposed to subtract sine 30. Okay, let's say I forgot sine 30. I go back up here, I check my exact value. Sine 30 is 1/2. So I go down here, I go subtract 1/2. Okay, now you know that to multiply fractions, you do the top times the top and the bottom times the bottom. Well, the bottom times the bottom is root 2 times another root 2. And root 2's, when you multiply them together, become just a regular 2. And so you get 1/2 minus 1/2, which is 0. Okay, so let's go to GeoGebra and just check our answer for that. Make sure we did it right. Okay, so I'm going to go sine 45 times cos 45, take away sine 30. Of course, it gives me 0. Okay, let's try another one. 1 minus sine 30 over cos 30. Okay, so 1 minus. Now, sine 30, we just said, is 0.5, or let's say 1/2. And then this has to be divided by cos 30. Cos 30 was root 3 over 2. So let's go square root 3 over 2. Okay, so you got something that looks like that. Okay, I put sine 30 on the top, cos 30 on the bottom. Now this looks kind of complicated, so I'm going to remind myself, how do you divide fractions? You flip the denominator over, and then you multiply by that denominator. Okay, so you see I've taken the reciprocal of the denominator to put the root 3 on the bottom and the 2 on the top, and now I can subtract. What do I get here? I get 1 minus The 2's, both 2's here can cancel, right? Because you got 1 times 2 on the top and then 2 times root 3. You have a 2 on the top and a 2 root 3 on the bottom, so we can just reduce that down to 1 over square root 3. Now, at this point, you should be wondering, okay, how do I actually make a common denominator here in order to solve this? What I would suggest actually is we rationalize. So I'm going to just put that in bold over here. Rationalize the denominator. Multiply top and bottom by the root. Okay, what happens? So I'll just write what I'm doing here. Okay, so what I'm going to do here is I'm going to multiply the top and the bottom by square root 3 divided by square root 3. Okay, so I multiply the top and the bottom by root 3. What happens? I get 1 take away square root 3 divided by 3. You see that? The top times the top, 1 times root 3 gives me root 3. Root 3 times root 3 gives me just regular 3. Now I can make a common denominator, 3 over 3 minus root 3 over 3. And there's nothing you can do with that. Just 3 minus root 3 over 3 is the answer. That's it. Like you can't make it any simpler than that. Okay, so that's the exact value. That's the answer I would be looking for if I asked you this question. Notice if I put this into my calculator, right? It does not give me an exact value. It gives me a non-terminating decimal. That is not the answer if I'm asking for the exact value, right? What I'm asking for is this: 3 minus square root 3 divided by 3. Notice it's the same number, but it's in the exact form. It's not in a decimal form. So if it says exact values, that's what I'm looking for you to do. Okay, let's try this one. 3 sine 60 times tan 60. Okay, so 3, okay, times sine 60. Now sine 60 was root 3 divided by 2. And tan 60 was root 3 over 1. Root 3. Okay, so let's just double check that I did that right. Tan 60 is root 3. Sine 60 is root 3 over 2. Okay, so I'm just replacing those trig expressions with what I know they're equal to. Now I have root 3 times root, so let's do the top times the top times the top. 3 times root 3 times root 3. Okay, the two root 3's multiply to make 3. That 3 and this 3 make 9, and you get 9 over 2. Okay, and that's all there is to it. So let's just check it. 3 sine 60 times tan 60. Oops. Oh, it did degrees automatically. Okay, it gives me 4.5. 4.5 is 9 over 2. So that's where that's coming from. Okay. Okay, now it says using exact values, show the following. Sine theta over cos theta equals tan theta when theta is 30 degrees. Okay, so let's split this into 2 halves. Okay, we're going to do a left side and a right side. Now, the idea when you're doing a proof is that you cannot move things from one side of the equation to the other. So you have to use equivalent expressions on each side. Okay, so that's what's on my left side. On my right side is tan of 30 degrees. Now I cannot move. If this was an equation, I could, let's say, multiply both sides by cos to bring it over, right? Can't do that in a proof. You have to leave the two sides alone. So you just have to try to work it out in an equivalent form. Unfortunately for us, that isn't too difficult to do here. We know that tan 30 is 1 over square root 3, right? Again, if we're not sure of that, we just go back up to our thing and check. Tangent of 30 is 1 over square root 3, so that's that done. Doesn't seem like there's anything else we can do with this side. So let's concentrate on the left side. Sine of 30 is 1/2. And then we have to divide that by square root 3 over 2, right? That's what the cos 30 is. Now we know that to divide is to multiply by a reciprocal. So we do 2 over square root 3, like so. And what happens? We get 1 times 2 on the top is 2, and then we get 2 square root 3 on the bottom. Of course, the 2's can cancel now because all we have is multiplication, and we have 1 over square root 3 as our answer. At the bottom of our proof, we say left side equals right side. Therefore, the statement is true. Okay, and that's how you do a proof. Now again, this is a fairly simple one, but as we go through the unit, we'll be looking at harder and harder ones, and it's just good to learn it right the first time. So that's all you got to do here is look at the left side, work on it, change it around, write it in a different way, fill in what you can fill in, that type of thing, and then work with the right side and try to show that the two sides eventually get to. I see what I did. Sorry. That the two sides eventually get to the same thing. Okay, sorry, just make sure this is fixed. Okay. Alrighty, so that's done. Let's try another one of these proof questions. So left side equals right side. Therefore, the statement is true. Okay, this one. It says sine squared theta plus cos squared theta equals 1 when theta equals 30 degrees. Now, first of all, what does sine squared x mean? Oh boy. What does this mean? Okay, this means you do a single sine x and then you multiply by another sine x. So it's like sine x times itself. Okay? Or another way of thinking about this is you do a big bracket, sine x, and then all squared. So it's just that a more convenient way to write it is to put the 2 there. But this is what this means, okay? When you see a 2 here, it doesn't mean theta is squared, right? Because we can't say this, because now it's the x that's squared, not the sine. Okay? So it doesn't look like that. It looks like either like this, sine times sine, or the whole thing sine x squared. So let's see what we could do here. The first thing, so let's write it out this way, just so you can see it the way I'm thinking about it. So I'm gonna write this out a little bit differently. I'm gonna say it's sine theta, okay, times another sine theta, plus cos theta times another cos theta equals 1. That's what the expression is asking you to do. Now, we also know that the theta in the question is 30 degrees, so let's put 30 degrees in each of these. So sine 30 plus cos 30 equals 1. That's the contention. Okay? Now again, technically what we should do here is we should be splitting it up into a left side and a right side. So left side, right side. Let's just fix up what I've done here. So on the right side I have 1. And there's really nothing I can do with 1. So this is what's going on my left side. So I'm writing it out, replacing theta with what I know it to be equal to, which is 30 degrees. Now I'm going to say, okay, sine 30, that's 1/2. Sine 30 again is 1/2. Cos 30 is square root 3 over 2. And then I'm multiplying that by another square root 3 over 2. Okay? Now what happens here when I actually do this arithmetic? You follow your order of operations, right? 1/2 times 1/2, you do the top times top and the bottom times the bottom, gives you 1/4. Now over here, you do the top times the top, root 3 times root 3 is regular 3, bottom times the bottom is 4. You get 1/4 plus 3/4, which is 1. Okay? And so, again, since the left side equals the right side, the statement is true. Okay? So we were able to show that the left side is also equal to 1, which is what the right side is equal to. Okay? Now, last task for today is to find the exact area of this triangle. This is a complicated task, right? This is something I'd probably have you do in groups if we had that option. But let's think about it and see if there's some way we can figure out how it should be done. this 45 degrees, okay, let's start with naming the parts of the diagram. So what I'm going to do is I'm going to sketch this. Let's sketch it over here, and then we'll just give it some names. So first thing I need is I need a 45 degree angle and a length of 6. So what I'm going to do there is I'm going to make a circle centered at O with length 6. And then I'm going to have a point O, and then a point at 6, 0. I'm going to rotate the point A 45 degrees, and then I'm going to make a segment from O to A prime. And there is, what we know about the triangle. This is 6. Now we know that this drops straight down, so we have a, let's make a new point here. X of A prime and 0. So there's our point. Can hide this one. We don't need it. We don't need the circle either. And then we have a third point C, which is out here, and that measures a specific angle. So let's go segment A prime B. Let's call that one H, since it seems like a reasonable thing to call that H. And then I need another point somewhere over here, not exactly sure where, that has to join the rest of my triangle together. So this is what we've got. And again, I'm not sure that point C is in the right place, but let's just get everything on a diagram that we can actually see. Okay. So in a complex triangle, it's probably easier to rename all of the sides the two things that they connect. So for example, I'm going to call this OA. I'm going to call, let's just hide the label for this. Okay, I'm going to call this bottom part CB. And call this bottom part B, sorry, not CB, I'm sorry, OB. Okay. I'm going to get this, rid of that label, and we'll call this AC. Okay, and I might as well just rename the H too. I thought it would make sense to call it H, but it probably makes more sense to just call it BA. Okay, so that's how I'm going to label everything in this triangle. What I currently know is I currently know that angle BOA is equal to 45 degrees. I also know that side length OA, we know that this one has a value of 6. So let's go name end value, OA equals 6. So that's what we've got right at the moment. Our goal is to calculate the area of the triangle. We also know that the angle down here in the corner is 30. So let me measure that. Oops. And you can see I didn't quite put this in the right place. It's got to be a bit closer so that this is 30. Somewhere like there. Somewhere there is fine. Okay, so something approximately like 30, but again, I don't have the exact value, so I can't draw it perfectly yet. What would help me to solve this triangle? It would help me to know, something about OB or BA, and then maybe once I know BA, I will know two pieces of information about the other triangle. Remember, any triangle, any right triangle, is solvable with two pieces of information, except angle. So if it didn't tell you any side, well, let's say two pieces of information, as long as at least one is a side length. So let's think about this for a sec. In the first triangle, right, this triangle, ABO, I know an angle and I know a side, and I also know the 90 degree, right? So I should measure the 90 degree here. Just change it to, okay. Okay, so really I know two things, right? So let's just say C is equal to 11.580. Okay, so there we go. All right, so I know that that's 90. I know this is 90. And again, probably want to rename these angles so that they make a little bit more sense. I'll call this an angle ABC because it joins A to B to C. And I'll call this angle here OBA, or AOB, I guess. Okay, I'll rename this angle in the corner. I could just call this angle O because of where it is, but just to be clear, just to keep it, I'll call it angle BOA. Okay. All right, so let's talk about the triangle on the left. I know 3 pieces of information: the right angle, the 45 angle, and the hypotenuse. Therefore, this triangle is solvable. On the right side, I know 1 angle, 2 angles, but I don't know any sides. So this triangle is not solvable. However, side BA is common to both of them. So if I can get BA using the left triangle, it gives me enough information to solve the right triangle. Okay, though when I say right triangle, I mean the triangle on the right. They are both right triangles since they're 90-degree angles. So let's delete this picture and replace with this picture since it's more useful. Okay, so let's start with something we can do. Side length BA, okay, is the opposite from angle BOA, so the 45 degrees that I can see. Okay, therefore, okay, sine 45 degrees is equal to BA, which is the opposite, divided by 6, which is the hypotenuse. Okay, BA is therefore equal to 1 over square root 2 times 6, right? So, let's go through it a little bit clearer. So, BA. So let's move this. Let's move the 6 to the other side. 6 sine 45 equals BA. I know sine 45. It's 1 over square root 2. Okay, doesn't work if you do it that way. Okay, 1 over square root 2 is that, right? So you get this is equal to BA. So we can just make that a little bit simpler. If we just go 6 over square root 2 is the side length BA. Okay, now this triangle with a 45-45 triangle, we know, so let's write down underneath this, in a 45-45-90 triangle, the 2 non-hypotenuse sides are equal. So therefore, OB must also be 6 over square root 2. Okay? Because in a 45-degree triangle, this side and this side have to be the same. So the area of the triangle on the left wouldn't really be too hard. The area of triangle OBA, that's right, would be base times height divided by 2, right? Just say BH. Okay, base times height divided by 2. Now look at the picture. The base is OB, the height is BA. So we're just going to do area equals OB times BA divided by 2. And the area is therefore equal to 6 divided by square root 2, okay, times a second 6 divided by square root 2, and then all of this divided by 2 at the end. Okay, so what do you get here? You get 36 over 2, and then you have to divide it by 2 again. 36 divided by 2 is 18, divided by 2 again is 9. Okay, so the area of the triangle on the left is exactly 9. Now when I go back to GeoGebra to check that, let's go polygon ABO, and you can see the area is 9. You know, even if I round it to 10 decimals, the area is still exactly 9. Okay, so we've got the exact value for the area on the left. Now let's talk about the triangle on the right. For the triangle on the right, we know that the height is BA. So for triangle, so the second triangle, which I've called ABC, okay, the height is again BA. The base is BC. Okay, so what do I want to do here? I want to go BA times BC divided by 2. Now, I can't quite jump to that right away, so let's go area ABC equals. Okay, I can't jump to that right away because I don't actually know BC. So what do I know that could help me get BC? If I look from the perspective of this 30 degrees, the opposite is BA, so let's write this down. So from the perspective of the 30 degrees, BA is the opposite, BC is the adjacent. Therefore, tangent of 30, right? Tangent of 30 is equal to the opposite, BA, divided by the adjacent, BC. Let's fill in what we know. Tangent of 30 we know is 1 over square root 3. We know that exact value from earlier up the page. Okay, we know that BA is 6 divided by square root 2. And all of this would be divided by, all of this would be divided by BC. Okay, so something like that. Now, okay, so just make sure I did this right. Let's go back and double check tan 30, which is 1 over root 3. Yeah, so we're good. All right, so this is what we've got now. Let's bring BC to the other side. So BC times 1 over square root 3 equals 6 over square root 2. So that's what we know. Again, if I want to move a multiply by 1 over root 3 to the other side, then I bring it over as division. Okay, so it would be divided by 1 over square root 3, because I'm dividing it over to get it over to the other side. Of course, to get rid of it now, I need to multiply by it, right? Okay, we bring the square root 3 on the top and the 1 on the bottom. And sorry, not equals, it should be multiply. Okay, so that's what we end up with. So BC is equal to 6 root 3 divided by root 2. Okay, and that's the length of BC. Now, if I go back here for a second and I define C, let's go back and just figure this out. So it would be A plus 6 root 3 over 2, or length. Uh, 6 times square root 3 divided by 2. Oh, I see. I see. So, all right. So let's just type it in. What did we say? This was 6 over square root 2. Okay. Just quickly. Sorry, I wanted to just get this exact number, but oh, I see. I forgot to say it had a y coordinate because it was a point. Oh, sorry, this is square root 2. Alright, now, if I put C in exactly that spot, you notice that the angle that I couldn't get right before is now exactly 30 degrees, even down to 15 decimal places. So C is now in the perfect spot to actually generate an angle of 30 degrees, right? So we found out the perfect place for C to be. Now, to get the area, so let's finish off here with the area, we need to do BA times BC over 2. So let's do that. BA, we said, is 6 over square root 2. So we're doing BA times BC over 2. Okay, so we do that. Multiply by this one, so 6 square root 3 over square root 2. And then the whole thing has to be divided by 2. So let's see what happens when you work this part out, right? You get on the top, you get 6 times 6 times root 3, which is 36 root 3. On the bottom, you get 2, but then of course you're dividing by 2 again. Dividing by 2 again. So you get 36 divided by 2 would be 18 root 3, but then you divide again and you get 9 root 3. And so this is the area of triangle ABC. Okay, is 9 root 3. So the combined area is 9 plus another 9 root 3 because the first triangle had 9, the second triangle had 9 root 3. You can't join these together, remember, because one has a radical and one doesn't, so you just leave it at that. Now let's check this answer with what GeoGebra says. Let's have it draw a polygon ABC, so the right-sided triangle. It comes up with an area of 15.5885. Let's compare that number to what we think it should be, which is 9 root 3. So 9 times square root of 3 gives us that exact value, right? The exact same number. Now, so the area of the entire thing now, let's see what we said it should be. We said it should be 9 plus 9 square root 3. Okay, so the whole thing should have an area of 24.58846. Let's go polygon OAC. So this time it's drawing the whole polygon, and you can see its area is 24.58846, exactly as we said. So this is a really good question. It takes some time, it takes some thinking, but it really does show how you can use these exact values to solve something that you wouldn't have been able to do in grade 10 or before doing this lesson. Again, it's just step by step. Try to follow what I've done, then do it yourself, without any assistance. So again, angles of 30, 45, and 60 you should know. You should memorize these two triangles, or at least have them accessible whenever you're doing any work. And please post any questions or follow up to the website.